Now that we know about variables, loops, and conditional statements, we have all the building blocks we need to write interesting programs. But just because we know how each one works, does not mean it's easy to write complex programs using them. Even if you know how to use all the tools, building a house is more complex than building a wooden mailbox. The larger and more complex the project, the more difficult it is, and the more planning that is necessary. In the next few videos, we'll look at how to approach larger programs. Instead of looking at a finished program, we'll go through each step of solving a program that is larger and more complex than we've written so far. The program we will write simulates a number of racquetball games. The idea is to determine what percentage of games each player should win based on their respective abilities. Simulating one game won't tell us much, and if we only wanted to do that, we might as well just have the two players play one game. Since the computer can quickly do billions of operations, we can simulate a large number of games, and that should produce a reasonable estimate of the percentage of games each player should win. Here are the basic rules of a racquetball game that we need to understand to write the simulation. A game is played to 15 points and you only need to win by 1 point. If the player serving wins the rally, that player earns a point. If the player serving loses the rally, the other player gets to serve. Recall from the earlier chapters, the first step in solving a problem is to understand the specifications. The specifications for this program will be how likely each player is to win the rally against the other player when they are serving, and how many games to simulate. The outputs are the number and percentage of games won by each player. We need a way to randomly choose who wins a rally based on the input values that indicate the likelihood of a player winning the rally. Python has a random module containing a number of functions. We'll discuss two of those functions here. The randRange function returns one value from the range of values the parameters indicate. Parameters have the same meaning as they do for the range function. randrange of 10 returns one integer from 0 to 9. randrange of 2, 20 returns one integer from 2 to 19. randrange of 2, 20, 4 returns one integer from the set 2, 6, 10, 14, and 18. We could use the randrange function, but I think the random function is a better fit for this problem. This can be a little confusing as the module is named random, and one of the functions it contains is named random. It's the same thing as if the math module happened to contain a function named math. The random function returns a floating point value from 0 to 1, including 0 but not 1. If a player has a 60% chance of winning a rally, we can use the random function and check if that number is less than 0.6. As 60% of the time we call the random function, we should get a number less than 0.6. We'll look at a few examples so you can see how these work. The first thing to note is that because the random module contains many functions, I only wanted to import the two we are planning to use. In general, it is recommended you import only the items you want to use so you do not end up with any naming conflicts. We can import multiple items in one line, or as the commented out code shows, we could have done it with 2 lines. We'll debug it and see that each time we call randrange with 10, we get back a number between 0 and 9. We'll call random 3 times and see that each time we get a number between 0 and 1. Again, this value might be 0, but it will not be 1. Next we'll resume and see that if we call random 1,000 times, approximately 60% of the time the random number will be less than 0.6. We'll run it a couple more times and see that it is not exactly 600, but is reasonably close to it.